All right, guys, we're gonna start 3:30. I'm just gonna start by emphasizing on the note. Well, it's our first meeting, so we're gonna go over some logistics for the working group. So as note, well, just be mindful when you sign and register. We agreed to a few policies. Be mindful about what we say because everything is recorded for an IPR and privacy perspective. Um, the note really well is really to emphasize on the anti-harassment, be respectful amongst each other when we talk. We are trying to um, be professional between one another. So if there's any hostile or raise of voice, please take this off in the corridor, I would say. For the people that are in the virtual meeting, be also mindful for between us in the room versus the people that attend remotely for the mic and the questions. And the logistic, make sure that you are registered with the QR code. Um, and that's it. We're gonna move to the, oh, we have minute takers. I think we're good to go for the rest of so we go to the charter. You wanna, yes, it's stuck. Yeah, yes. Okay, for the agenda, we're going to, we just started the introductions. In the introduction, we're going to go over the charters, the milestone. We're going to recap a little bit around the charter. We're going to have a few words from from Jim, the AD, and then we're going to go over some presentation from operators. We're going to start with Verizon, then China Unicorn, and Rakuten. And then we're going to review the draft that are already submitted in the content. Charters and milestone.
Yeah, so since this is our first meeting, we wanted to set the stage right. Let's all go over the charter that we have all agreed to so that we can avoid confusions over what work belongs in this working group. And also go over the milestones that have been agreed with the ISG. So this is our main description of the charter. We are going to focus only on the operational aspects, and we will focus mainly on the SRv6 network. So things which are very IPv6 generic, that doesn't belong here. Things which are common with SRMPLS as well as SRv6, that also doesn't belong here. This is going to be specific to what's happening with the SRv6. We are a generic forum for network operators to come and discuss. That's why we have those operator presentations, and even in future we want to invite more of these kind of presentations. So when you guys are outside and meet operators in other forums, tell about SRv6 Ops, ask them to come and present about what they are doing, what are the challenges they are facing. So we want to make sure that we act as a good forum for this kind of discussions. Our aim is identifying operational challenges, and if we can also agree on good operational guidance that we can give for other operators who are starting with their SRv6 journey, or are there some pitfalls that they should be well aware of. So that's our main objective. The scope, we will be focusing on informational documents only, so there is not going to be any solutions work. We will not be updating any protocols. There was initial discussion whether BCP is in scope or not, but at that time we decided that let's keep it scope for now, focus on guidance, focus on informational documents for now. But as we gather more and more experience, we could of course recharter and include BCPs in future. One more activity that we will do is there is a lot of work which is in Flex, a lot of development happening in Spring. There are SR extension in various different working groups. So we need to make sure to have clarity on what belongs in operational aspect of SRv6. So we will make sure that every time we adopt any document, we will consult with the responsible area director, who is in our case also responsible for Spring, so we could have a good coordination between the two groups. And things which are still in under development, we will try to be careful and not create confusion with the same discussion happening in two different venues. The things which are still in development in other working group, it's best they are discussed in those working groups itself. Of course, there could be some presentations here for inviting more participation, gathering operational input, but the real work belongs in those working groups. Our scope, operational issues and requirement. We will talk about new innovative deployment scenarios. What are the new guidance from operational side, management side, observability side that we can get from the operators. So that's our main scope. The deliverables, again, coming from documenting issues, experiences, guidance at various different levels. So some of them are highlighted in the charter text itself, especially with respect to address planning, the strategies around how do we allocate our global blocks, how do we do compression strategy with address planning, things like that, and network management guidance, as well as observability techniques. We need to cooperate with a lot of working groups, so that list is there. Spring, we need to have a good and close cooperation, as well as various different working groups that are listed here. We will make sure that we will cross-post things across working groups so that people are well aware and we don't do things in silos. And final bit, this is our set of milestones that we have. Our main aim is to work on a document which describe operational and management issues. So that's what we will be working on first. And then there are a bunch of other things that we have highlighted. And of course, these things can change. So if there is, based on the working group feedback, if some milestone needs to be added, updated, feel free to reach out to the chairs. And that's all about charter. Now we want to give floor to Jim. Jim, this is our first meeting. If you have any words for guidance that you can give to the working group, floor is yours.
Thank you, Drew. Can you hear me okay?
Yes.
Okay. So first of all, an apology to the working group. I was planning to be there face to face, but I got crowd struck and my flight was cancelled. So hence I am remote. So I do apologize for that. I'm pretty excited about this working group. I think it's nice to see in the IETF a working group that is able to be formed to work on a technology that's pretty heavily deployed out there and growing rapidly. But as we chartered this working group, we were very, very careful to make sure that we don't have any overlap with any other working groups. And specifically, the one I'm thinking about is Spring. And one of the things that we agreed was that I would take over as responsible AD for this working group so that I can closely monitor what happens here as well as in Spring to help make sure that there's no issues between the two working groups. Obviously, as was said by Drew, we really need to pay careful attention to the charter, making sure that we stick to that and we only work on things that are within that charter. I will say that I'm in conversation with the Spring chairs at the moment to work on their charter. There was a little bit in that charter that overlapped, and we're in the process of cleaning that up. That was something that I agreed to as part of forming this working group. So I guess to underline, this working group is not a replacement, nor is it an extension of Spring. I want that to be very clear. And hence, we've been very careful on the charter, and hence that I took on the responsibility of the AD for the working group. And I guess in closing, thanks to the chairs for stepping up. I really appreciate that. It's going to be a pretty exciting working group, I think, with lots of interesting information coming from our operators, which are using the technology that we're developing here in the IETF. So So again, thank you to you guys, and back to you.
Thanks, Jim. Let's start our session.
Good afternoon. Do I have the slides up? Okay. So my name is Loay Jalil. For some, for people that don't know me, I'm a distinguished fellow in Verizon, and today I'm going to talk to you about SRv6 in Verizon. When I first was asked to make this, my immediate thinking was to talk to you about our SRv6 design and architecture. But I thought, why would you want me to tell you how to design SRv6, regardless if I'm talking to the vendors or operators? Instead, I'll tell you why we're going down the path of SRv6, what is our motivation, and what is our requirements. So next slide. All right. So I'm going to talk about the Verizon network in general, just to show you kind of the size and the amount of services we have. I'll talk to you about the motivation, why we needed something new and different. And then I'll talk to you why SRv6 specifically and our requirements for it. So I'm trying to be kind of brief here and not spend a lot of time and get into it. We have a lot of Verizon networks, large and small, and even the small ones are actually part of the large network, but each has its own administrative domain. And all these networks are kind of interconnected magically, between them to offer some seamless services, regardless of these services. And as you can see, between consumer, business, financial, government, wireline, wireless, you name it. The one correction I would make on the diagram, I duplicated consumer fiber to the home twice. One is enterprise, one is consumer. So that's the only correction I would make here. We actually utilize a lot of traffic engineering. We started all the way from RSPTE. We're a big RSPTE shop in some areas. We use SRMPLS, and we're slowly getting in SRv6. We actually, outside of traffic engineering, we still have LDP in some places, but a lot of it is going to evolve and become kind of the new evolution to say, what is the new thing, what is the better thing, and why do we need it? Next slide. By the way, I'll probably go through these things really fast just because of my speed, so let me know. I'll probably save you some time. So what is the motivation? We have a lot of applications today for different network function, regardless if they're physical, virtual, containerized. So we need to be catered for all these services. We actually have to be software-defined networking, for lack of better words, but there's more control from a software-defined perspective, and then general virtualization needs. Consolidated footprint. Footprint is important for us. Power, space, and cooling is becoming, as we're growing, and growth is becoming, power, space, and cooling becoming critical. So we want more efficient network equipment and minimize the footprint in some places where we can't even fit our big, large boxes of routers. Enhance and simplify routing. That's always been a goal of ours. How do we efficiency and manageability so we can simplify for our operational team? Application-aware routing. I know some people might think applications have to care for themselves, and in some cases they do. But in some cases, we actually own even the applications, and we have to cater for them. So we want some application that are based on, aware of what it needs, and the network can kind of cater to it. Service velocity, we have a huge network. Time to market is very important to us. On top of getting stuff tested and certified and even introduce it in the network, it takes a while. So we want to be able to do this at a faster pace so we can offer new services faster. Centralized controller to get a holistic view of the network. As you can see, we have multiple domains in the network, and every domain looks at its own self. Maybe you can think about it in a silo, but however, we actually want the holistic view. The centralized controller looking at multiple domains of the network becomes important to us. Optimize edge routing. As much as I went to and we centralize and we look at our centralized stuff, as you go through the services, you realize we need some distribution. However, we need some more efficient distribution. So how can I optimize my edge routing, especially when we start talking about network slicing, mobile edge compute, and all the other stuff that actually is closer to the customer. So these things become important. So it's not one way or the other. So we have centralization, but we need some distribution for some routing. And then at the end, I think that's always been a goal, to simplify routing. Can I simplify the number of protocols that I create and simpler? Just because we're coming from a world where almost every single thing needed a protocol. Now maybe one or two sets of protocol can serve what we need. Next slide. All right. So SRv6, where do we see SRv6? I draw all these networks and services to you, but they're really residing in all these locations. So between wireless locations, data centers, and data centers could be in wireless and wireline. A Verizon cloud platform, that's our own compute, our own internal cloud platform that resides in multiple locations. Fios, and I probably should have generalized this, but this is fiber to the home, our services, our GWRs, our BNGs, all that good stuff. Wireless mobile switching centers, we have those. Radio access network, I mean, this is a large amount of smaller sites, huge in a huge amount of numbers. And then hub and regional hubs, those are more specific to our kind of a metro, ULH kind of a terminology. That's what we call them, hub and regional hubs. And then we have global existent international sites. Some of you know us of 701, 702, 703. You pick your AS depending on what country you're in. But we have presence for our actually enterprise services and internet services internationally. So the next slide is going to talk about why SRv6. And some of this stuff is redundant. You'll actually see it, but simplified protocol stack. So I think it meets it. Uses IP only, eliminating the need of MPLS. Doesn't mean MPLS is bad. But as we simplify the protocol, SRv6 kind of meets. Remember, we're doing SR-MPLS in a lot of places, but I'll talk about it in a minute. But to simplify the protocol is important. Advanced traffic engineering, business rules, constraints. These are, as we get into different services, regardless in the wireless, especially on the 5G side, as new services come up, and even wireline, as we're trying to kind of even the services between wireline and wireless, we need these advanced traffic engineering capabilities. Seamless end-to-end connectivity using SR. Again, back to the encapsulation symbol protocol. If we can get it across multiple domains. I mean, the picture that I didn't show you here, when you take a call flow from the beginning to the end, you're actually going across a service. I'll give you an example. You go through wireless, then you go to metro, and then that's another domain. You come back to wireless, then it hands it to wireline, depending on if you're going to the internet, whatever. So there's a lot of really networks that this call flow goes through, and we need that seamless connectivity between them. We're a big RSPTE shop. We have RSPT in a lot of places. Reducing the need for those TE tunnels makes it simpler for us. Maybe we can eliminate them at some point, but my goal right now is reduce the need for all these tunnels that we're building for the different services. Comprehensive support, we're actually big on doing SR in the fabric or on the WAN. Some people might look at it differently, but we want to be able to have that comprehensive support both in the fabric and on the WAN. Network slicing is important to Verizon, and we believe that SRv6 meet the industry network slicing models and even for Verizon. Selective device support, that's required that we can actually add devices that don't have support SRv6. I want to get to the last, actually, 3. So Linux OS compatibility. So this is one of the main ones that drove us to SRv6. So we had SR-MPLS. We wanted the compute to be part of the SR domain, and working with different people from the Linux, we couldn't get SR-MPLS or actually MPLS support in Linux. But SRv6 was a much easier lift. So this is why we're actually part of this is support Linux. Unlike SR-MPLS, we're actually big on going to SRv6 just to include that. Remember, we do a lot of softwareization on our devices. So a lot of our service is actually residing in some network function. So we need to be able to make that part of the SR domain. And that's where the last point is. If we integrate that compute as part of these services, then we can do end-to-end traffic engineering. Let's go to the next slide. I think it's the last slide. So what is our requirement? And again, you'll see those are being repetitive. So seamless transition, we cannot flip the switch and go to SRv6 or any other protocol. So we have to have a transition period. So interworking and interoperability is very critical for us. We need to have a smooth transition. Without that, it's hard for us to move from one protocol to the other without a big forklift. So that's important. Functionality, and the reason I call it functionality versus feature, because I don't like to call features by name. I like to say what the function of that feature can I satisfy with the new protocol. So at minimum, I have to maintain the same functionality capability that I have, and then some. We know there'll be advanced stuff, but at minimum, we're trying to maintain the current needed functionality we need in our network. The scale architecture, as you can see, we have different sizes, different places, some in the core, some at the edge closer to the customer. So we need the right size, and we need to make sure that that protocol can accommodate this right size. I saw the note, what was it? Resilient, secured, Efficient, very important. And they're all kind of fall in. So reliability is one of our currencies. So we have to always maintain reliability and resiliency. So any protocol we do has to have that resiliency built in, or if it's not, at least seamless, so we can have that, from a reliability perspective. Risk mitigation security, comes together. These are a must. Open standards, open APIs, and I'm just going through this stuff. I mean, this is, you can read it yourself. I'm just trying to kind of add some flavor to it. A failure domain reduction. We actually have to make sure that from a failure domain, how can we isolate failure domain? What is the blast radius? And we need to make sure the protocol we do can minimize those failure domains reduction. And at the end, and not that the least important, it is, I mean, it's not the least, it's the most important, and actually falls with everything, is to focus on the cost per bit. So anything we do, we look at the cost efficiency, and that cost efficiency is not just equipment cost. What is the equipment? How much does it get to power it? What is the space? How much to manage it? So all that stuff, when you do a total cost of ownership aligns together, that's how we do the cost per bit. And it's not just capital, it's CapEx and OpEx. I'm actually done with this, and maybe I'll give you some time here. You want to leave the question till the end, or?
If you have any question, now is the time.
What did I do?
Or comment.
Please use the QR code.
Hi, thanks for your presentation. Mike McBride, FutureWay. So in meeting with customers this year so far to discuss SRv6, the two primary questions that have come from that, the first of which you answered is, what does SRv6 give me over MPLS? And you kind of discussed that, which is great. The other one is, which goes along with this slide, is in brownfield environments, is there any help with transitioning from our existing brownfield environment to an SRv6? Do we tunnel or some good, they could use some good advice on those transition mechanisms. So you've listed the requirements. I'm not sure if it falls within the charter of this working group, but that would be something that would be a helpful document to kind of talk about transitioning to SRv6. Does that sound reasonable?
Yes. First question, please use the tool. We all agreed that we will get in a common meet echo for both remote as well as in person. So people who are queuing up, please make sure to join the queue. Thank you. And second is, yes, we have in fact one document initially. So our question would be that we would like how to convert this into useful guidance into the documents worth documenting as a part of our document that SRv6OPS can work on. So we need to convert these requirements clarity on what are operational challenges, what are the gaps that are currently there in the existing standards, and what future work that can be done. So let's break this down into a little bit more granularity. That would be needed. But as a first presentation, I think this was very good to set the stage and to set at higher level before we go down into those weeds.
Agreed. Thank you.
And just to add to that, I'll tell you, we have an initial experience in some of this stuff, but there's a lot of work to be done. Looks like even some inner working, I've seen some inner working drafts that I think could be helpful here. So I think there's more work to be done. And I just didn't want to set the stage telling you how I'm doing it. I'm just set the stage as a community. We need to make sure that these things in place to make it easier for operators to kind of deploy these technologies with these.
Agreed. Thank you.
Thank you. Nick?
Hi, Nick Braulio, ESNet. And I'm going to ask an operational question here, and you can tell me if this is the wrong place for it. But can you give a 10-second synopsis of what you've done as far as doing risk management and perimeter filtering with SRv6?
I mean, that's not the scope of this discussion, so we can have this discussion offline if you need to. Yeah,
I can talk to you afterwards about it.
But please use the mailing list. That's what it is
Yeah,
for. Let's have
that's
those
right.
discussions.
Yeah.
Yeah.
That's okay.
Tony. Oh, Ketan first. Yeah.
Ketan Talaulikar, Cisco. Just to answer Mike's question, there is a draft currently in the working group adoption in Spring working group for interworking between MPLS and SRv6. So please do review that and give your comments. Thanks.
We need those drafts.
Tony Lee, Juniper. Also, I'll just point out that there's no reason why you can't run them in parallel, ships in the night.
I'll tell you, and this is not an SRv6 stage. So we've done some stuff in parallel ships in the night. It becomes costly to some point, depending on the size of your network. challenging from a operational domain, who controls what, and we've done it before. Not that it's can be done, but my preference, and we've got the people here to make it inner work. But if all fails, I guess that will be the last resort, is to do ships in the night. So I'm with you.
Any more questions?
Comments?
Thank you.
All right, thanks.
Shinshin, are you remote? Yes, go ahead.
Hello.
Yes, we can
Hello.
hear you.
Okay. Hello, everyone. I'm Xinxin from China Unicom. And today I share the topic of the use case and the requirement for SRv6 enhancement techniques in the cloud. And next slide, please.
I have given you slide control, so you should be able to change the slides yourself.
Okay, thank you. Okay, one of the typical scenarios of SRv6 technology is to provide the value added private line services through the service function chain. Like the figures show, customers use SRv6 provide lines for data transmissions, traffic scheduling through service function chain, and enter the cloud for processing by service functions. China Unicom has deployed these scenarios on the network in many places, like the Guangdong, Jiangsu, and so on, including the backbone network and the metro area network. For example, on our smart metro area network in Guangdong province, China, we can see we offer the secure private line product through SRv6 based service function chain. Based on the original SRv6 private line, enterprise customers can schedule traffic to the cloud through the service function chain and invoke the mobile application firewall and in the Guangdong MEC and the firewall service in the cloud in the Taiyangcheng MEC. In this way, on the one hand, customers get more services. On the other hand, operators can also get additional revenues. However, during the deployment of this application, we found some problems. The main reason is that there is not enough support for SRv6 on cloud devices. Then, when the service function chain is implemented, a proxy node needs to be deployed outside the cloud to complete SRv6 forwarding. In this way, when there are multiple service functions in the cloud, business traffic will be passed back and forth between the proxy node and the service in the cloud, thus affecting the efficiency of the service. And in addition, IPv6 and SRv6 are not supported in the cloud as well. So making it impossible to implement on-stream detection between the cloud and the network. This also affects the status monitoring of the customer line business and reduce the user experience.
Shinshin, your audio is very choppy. Can you maybe speak closer to the mic? Let's try something. If the audio comes clearer, can you try again?
Okay, sorry. Maybe we should repeat this page. Is that okay?
Yeah, continue. Let's give it a try. Otherwise, I'm not sure what.
Okay. Okay, sorry.
Remote folks, are you able to hear clearly? Maybe reaching? Is the audio clearer? Is it a room's problem or is it a problem at the? Uh,
Yeah, so the room, I think the voice seems good for me from
okay,
remote.
might be a room problem. I'll just report it on the Slack. Yeah, please
Yeah,
continue.
Xinxin, please go ahead.
Okay. Therefore, in the process of SRv6 application deployment, because the devices in the cloud cannot support SRv6 well, the end-to-end implementation of cloud network collaboration services is often difficult. First of all, for private line service based on SRv6 service function chain, SRv6 forwarding is not supported in the cloud, and only out-of-cloud agents can be used, which affects service efficiency. At the same time, because IPv6 or SRv6 is not supported in the cloud, the private line cannot be detected between the cloud and the network with the flow. In this way, the fault cannot be delimited and accurately located. So for the frontline workers, this can be a headache. By analyzing the above problems during the application deployment, so we proposed a solution. This solution is to deploy a virtual router in the cloud, like the Red router, which can support IPv6 and the SRv6 protocols. In this way, through this virtual router, on the one hand, the proxy function of the service function chain can be completed, so that the private line traffic can smoothly enter the cloud and perform the service function processing. On the other hand, the virtual router can also be used as a node for the IOM detection to detect the status of the service in the cloud. In this way, the operation and the maintenance is present and can well determine whether the fault is in the bare network or in the cloud.
Shinchin, the audio problem isn't resolved. Is there something that you can test from your end? Maybe we can come back to your presentation afterwards.
Okay. So I should exist this. Or I continue, or I repeat this page, or I.
Yeah, I think that will be the most productive. Otherwise, I think it's very hard to understand. So let's try this again. Jim suggests there are only 4 slides. Yeah, that's also true. Do you want to summarize this quickly? And if there's time at the end, we can of course try again. We are running ahead of time, so there might be a chance that we'll have time at the end. So I would suggest you summarize it, the key point that you wanted to get across. Thank you.
Okay. Sorry. So we can provide the scenario 1, the SRv6 based service function chain, like the speed like others. So we can give the and maybe give the summary of the topic is that we can consider provide a virtual router in the cloud. First, schedule of the cloud network cooperation. Virtual router with the SRv6 and service function chain to processing capabilities is virtualized in the cloud, and maybe the to scheduling capabilities and cloud value added service capabilities. And the second, we can to measurement of the cloud network operations. Through the deployment of IPv6, router and the innovation of IOM technology. The end-to-end high performance management of cloud network coordination service. So that's all. Sorry. We will to make the SRv6 application more and more readily. So thank you for listening.
Yeah, it's unfortunate that the audio was not good. But are there any questions? Maybe it will be difficult for Chin to answer with voice, but she can respond on the Meet Echo laterwards. So if there is any questions that you want to record, please come. Otherwise, we'll move to the next presentation. I'm not seeing anything. So let's go. Please use the chat. Maybe that would be the best way for feedback people have for the last presentation. If there's time, we can come back to it at the end as well. Thanks.
I'll start. Okay. Hello, everyone. This is Akash Agrawal from Rakuten Mobile Inc. And in next 10 minutes slot, I will share with you all about SRv6 implementation journey and lesson learned. Okay. I would go about the topics like the rationale behind our choice of SRv6, high-level SRv6 design, IGP design and scale issue, challenges with summarization and solution, SRv6 migration plan, migration approach, deployment outcomes, and we'll end the session with key takeaways. So I think we just covered in the Verizon session, we have obvious benefit of the SRv6. When we started our network, it was running on plain IPv6 hop-by-hop routing architecture. That time we didn't have much requirement of VPN. But later, when we decided to launch enterprise services, we assessed MPLS, segment routing MPLS, and SRv6. Because our infrastructure was on IPv6, SRv6 made most the sense. And also because it removes the extra MPLS stack. And I believe that removal of that extra stack will reduce the software issues. It returns to native IP routing and allows us to achieve hyper-scalability through prefix summarization. So high-level SRv6 design, the building blocks of any ISP network, which are topology, both physical, logical, IP addressing locator schema, employed protocols, services what we offer, as well as right levers for fast convergence. So quick convergence is very crucial to ensure no outage during network incidents, provided redundancy is there. So as you can see in the right side pic, this is Japan geography. This network is in Japan, and Japan is divided into 47 prefectures. But we have 59 IGP domains, few prefecture based on number of node density and the area size demand more IGP domains. And we have total around 14K, 15K SRv6 enabled node. That is scale and size of the network. On the addressing schema, we decided to go with EULA addressing. Not routable outside Rakuten network. This is F3216 standard. One block /32, we use 224/40 pools. Rest are reserved for lib. We allocated one or more this /40 pools to each IGP domain so that we can do summarization at the ABR level. So far, we have allocated 133/40 pools. That gives us total 57K locators, but we are using only 15K. That means we still have 74% available for network expansion. Once we do summarization in the core, we will have hardly 500 prefixes, and that's a major advantage of SRv6. High scalability. For any new flex algo, there's another /32 block from the allocated /24 block. And from the current addressing schema, we can use up to 8 flex algo. Next, on the protocol, what we have deployed, the bare minimum protocol, ISS for underlay, BGP for overlay, BFD for quick failure detection, EVPN for L2 VPN, LSAP for bundling, VRRP for FHRP, BGPLS for routing analytics, and controller-based SRT. Next, to achieve fast convergence, few levers what we use: BFD for failure detection, TLFA to react to a failure at IGP level, and BGP pick at the service level. On the services what we have deployed, it is 4G, 5G mobile services with over 7 million subscribers, fixed line internet, and now expanding B2B services, low latency path using SRPM and FlexAlgo, and effective bandwidth utilization using demand metrics are in plan. Okay. Now I will cover the IGP design. The left and right side, we have two IGP domains which are connected to core domain. This is just a depiction, but similarly we have 59 such IGP domains which are connected to core, and then we are doing redistribution at the ABR level. So now you can see that core has total more than 15K locators in its IGP routing table. Adding one more FlexAlgo would add another 15K routes, and this is not scalable. However, prefix summarization will reduce this 15K routes to less than 500, but still we have not done summarization yet. And why? Because prefix summarization capability of SRv6 provides ultra-high scalability, but summarization comes with one caveat. It hides the unreachability information. While redistribution hides only the topology information, summarization also hides topology as well as unreachability information. In other words, ABI creates the impression that it can reach all more specific prefixes, but this promise breaks in two scenarios. One, node fails, but RR and remote node still have next hop in its IGP, thus keep forwarding traffic to the down node till BGP will go down with the RR. Second, in case of area partitioning, ABR attracts traffic even for nodes to which it does not have reachability now. So what is the solution? So for first problem, we are using UPA, unreachability prefix announcement. If ABR would detect any node going down, which it was hiding earlier unreachability information, now ABR will advertise an unreachability prefix information. And on basis of that, RR or remote node can react to it for BGP pick or BGP convergence. For the second problem, which is area partitioning, the two ABR will talk to each other, send probe continuously. Once they detect no communication, they stop doing summarization and start advertising more specific prefixes. Thus, we avoid any black holing in case of area partitioning. This is a rare case, only in case of double outage, but still this can cause a major outage. So we wanted to go for this feature before we do summarization. So once we upgrade network to a next release where we have this two feature, we'll do summarization, and then we can reduce the number of routes in the core, and then we can add FlexAlgo to add more locators in the network. Okay, I will cover our migration strategy because our SRv6 deployment is 100% done. So yeah, for migration, we opted to create a parallel SRv6 infra by creating a new sub-interface on each NNI, new ISIS instance, and IGP redistribution. The speedy SRv6 infra deployment without affecting existing routing was possible with this approach. And once infra got completed, the connected hub node, which you can see here, AG4 routers, which are connected to data center, we used a unique solution of VRF light solution. So the interface going to data center is part of the VRF. Now, if node is already migrated, it will have VPN v6 route, and it will take SRv6 sub interface, SRv6 encapsulation, and will take the top plane, which is SRv6. If node is not yet migrated, it will take the VRF light, and it will take the bottom plane and plain IPv6 hop by hop routing. So once this setup was done, and AG4 is acting as a stitching point between two data planes, the rest work was step 3, which is just node by node, just migrate one node to the above plane, which is SRv6, and it was very simple migration, smooth migration. Okay, with this, we transform network transport network from a legacy hop by hop routing architecture, which you can see on the left side, to the to the current overlay underlay routing architecture using SRv6. This gives us more and better services offering using existing infrastructure. Single SRv6 fabric, a big SRv6 fabric, reduce the provisioning touch point, faster provisioning, and easy to automate, less human error also. In hop by hop routing architecture, it was very difficult to maintain routing consistency on all the node and also the config consistency, and it was causing outages. While in the underlay overlay architecture, it is very easy to maintain the routing consistency because it's a IGP and ISS, so it has to be consistent, and then it also reduces the provisioning touch point. Okay. We completed this slide covers the SRv6 journey. We completed this project in 2.5, 3 years. We spent around a year on planning, designing, and testing. We then worked with our vendor, Cisco, next 6 months to develop the automation, and a year on network-wide OS upgradation, SRv6 infra, and service migration. So it is very important to capture outcome of 3 years time and effort investment. So as a result of this project, we successfully reduced ISS LSP by 98% in the core, ISS total routes by 73%, number of BGP session in the core by 96% because we moved all the BGP to dedicated RS. Our total route towards the data center by 90%. We use prefix summarization that brings stability and scale in the data center devices. 86% reduction in config touch point. Now only two ends to configure for any service in this SRv6 fabric, and 90% improvement in the convergence because of TILFA and also reduction in overall routes. And we'll reduce this number of routes further after prefix summarization. I could not cover all the network improvements which helped us to reduce this many LSP and routes, but maybe can expand in some other one-on-one session. Okay, this is last slide, and all these numbers what we discussed in the previous slide, an improvement to the network is of less significance unless it is acknowledged by the operation team and translates to enhance user experience. This graph illustrates how service impacting occurrences decreased by 93% after our SRv6 deployment. So Q4 23, when we just completed SRv6 infra from 15, now quarter 2 24, when we completed migration, it has reduced to 1. And in month of May and June, we had zero service impacting P1, P2, P3 outages. Only the P4 incidences can continue in the network. Links, line card nodes can go down. BGP session can flap. But as long as traffic rerouting can be done within the application tolerance time interval, end users are not impacted. And we aim for zero outage as long as there is redundancy. So I'll just end this with summary and conclusion. SRv6 design brings network simplicity and efficiency to the Rakuten network. SRv6 usage brings ultra scalability because of native IPv6 forwarding architecture and summarization capability. SRv6 design also improved our network stability, we just saw in the previous slide. And it also provides us ability to route different traffic to meet application demand instead of vanilla routing only based on destination. Thank you. If any question, happy to answer.
Hey, actually, Akash, a very good presentation, by the way, it's done. Your second last slide, the slide just before this one, yes. So you were coming from which network design before? So you have now 92% reduction of incident. Was it like an MPS network or was it just an IPv6? What was it before?
It was just IPv6 network. We didn't have any MPLS because from day one we went for pure IPv6, and that time there was no MPLS or segment routing capability for a pure IPv6 network. So this improvement is from hop by hop IPv6 routing to the SRv6 routing.
All right, thanks. Any other question, comment?
I have a question regarding one slide you're showing for our six performance number improvement. Can you show that one? The last one, yeah, the 500 millisecond to 50 millisecond. Is
Yes.
that only for the routing domain convergence? Because I know Rakuten uses a virtualized implementation for your 5G 4G network. So is this
Yes.
only for the routing domain part?
This is only for transport IP domain part. Yeah, that is correct. Yes.
Okay, thank you.
Hi there, Tom Hill. Thank you for your talk, Akash.
Speak closer.
Oh,
thank you.
My apologies. Tom Hill from BT. Very interesting talk, actually. I like the detail that you went into. This is really interesting. The last slide that you had showed the reduction in service affecting incidents.
Yes.
Could you point to, and the answer may be no, but could you point to a particular feature of SRv6 that has helped you reach a lower number of service affecting incidents? What do you think has
Correct.
actually been the main
So,
difference?
yeah. It's not only SRv6 capability, but in general, overall network restructuring, re-architecting help to reduce these outages. And I mentioned earlier, in the hop-by-hop routing architecture, you need to maintain routing consistency on every node. If there's no routing consistency, uh, because then your ABA router that time, which we call AG3, was acting as a BGP route reflector. It has to reflect route on every router. In short, you have to maintain a routing consistency because decision is being taken on each hop. If there's a routing inconsistency, it can cause outage. Also, if that time also we were using summarization, and there's a more specific route exchange between two router. One router can attract traffic, but it cannot deliver traffic to other router unless there is a tunneling capability. In any tunneling capability, whether it's MPLS, SRMPLS, or SRv6, all such issues can be mitigated. So not only SRv6, but any tunneling where you have underlay overlay architecture, it's very easy to maintain underlay route consistency and route traffic using overlay tunneling.
Thank you for that additional detail.
Thank you.
Yicheng?
Yeah. So one quick question: how many comprise the seats in the packet for your longest pass?
Currently, we are not using SRT, and we also have plan only as long as possible use the flexible only. So currently, it is using only one seat, only the destination, and maybe one for only one seat basically.
Thank you.
Thanks, Akash. That was a very interesting talk. I would also request come and participate more in the working group. Let's work on what are the guidance slash challenges that we can be documented well based on your experience. So I invite you to come and participate.
Yeah, I just
as well.
would like to add one challenge, and I would like everyone to work on that. One deployment consultation for everyone is related to MTU because Path MTU discovery probably is not yet officially part of the SRv6. If that is not there in your deployment, then you make sure that your application packet size is less than your lowest MTU in the network. So that is one challenge that we should fix.
Thanks a lot, Akash.
Thank you.
Any other question for Akash? Otherwise, we'll move to the second part of our session. Okay, let's talk about drafts. Thanks, Akash. Yeah, Isong, go ahead.
Thank you, Chairs. Can you hear me?
Yes, I'll pass on the. I've given you the slide control.
Okay, thank you. Okay. Hello, everyone. I'm Yisung Liu from China Mobile. Today, I will introduce the SRv6 deployment and the operation problem summary on behalf of my co-authors. I will introduce from 5 parts. The first one is that the SRv6 interdomain deployment considerations. As we know that SRv6 naturally support the E2E interdomain by utilizing the IPv6 route reachability. So the IPv6 route aggregation reduced the number of SRv6 locators distribution for the interdomain deployment. And in the world, many operators may have deployed the MPLS or the SR-MPLS in their networks. When we when we want to run the SRv6, that's the problem one. The first problem is that how to deploy SRv6 in the existing MPLS network, which requires the consideration of existing mechanism and the potential migration strategies that may have SRv6 over the MPLS or the MPLS over SRv6, and also the SRv6 and MPLS interworking. In the interdomain deployment, we have another problem is that utilizing the SRv6 compression techniques in the interdomain scenario to further optimize the bandwidth usage. So which requires the effective IPv6 address planning and the block allocation strategies to achieve the optimal aggregation benefits. For the example of the deployment practice in China Mobile, we have at the first time we have two choices. One is that the E2E4 parts with the CC, and the other is that for the B seed, the binding seed with the CC, and in our network, and that the best practice is that for you use the E2E full pass CC, it's more effective. The second part of the problem is that the SRv6 data plane visualization. So when we want to provide the essential insights into the network traffic flow, resource utilization, and the potential performance bottlenecks. So we want to leverage the existing frameworks with the new parameters to define the SRv6 specific customization information that will we have the problem 3 and the problem 4. Problem 3 is that we want to use a telemetry framework. The telemetry framework used to collecting and transmitting the network telemetry data. The specific content and the parameters need to be defined to capture the SRv6 specific information relevant for the visualization. The problem 4 is that we want to use the network YANG framework. As we know, in the Spring, we have already defined the YANG model for the protocol extensions. So when we want to for a better operation on the maintenance of the SRv6, the YANG model for the information collection or status notification or failure handling and recover may also be required. So another aspect of in the data plane and visualization is that we want to use the network analysis and the performance of optimization for the SRv6 by the data collected from the network devices. That we have a problem 5, identification of net techniques for the performance optimization in operational scenarios. The third part is that the SRv6 address assignment considerations. For the existing IPv6 address planning approach ensures the efficient address utilization and simplifies the network management for the IPv6 network. Many operators has own SRv6 address planning, but which may not satisfy the SRv6 seed planning for the service provider. So especially consider when we use the SRv6 compression seed. So for the work, we should consider that the SRv6 seed block assignment. Another for the especially for the node ID and the function ID that is a relationship with the compression seed assignment. Also, we have the SR and P2MP. So we also should to consider the seed assignment for both the unicast and the multicast. We have some initial work for the draft, and today Mr. Zhu will give the presentation of this draft. And the fourth part is that the traffic steering to SRv6 network considerations. As we know, there are various SRv6 traffic steering methods. So everyone make them with their own unique advantages and challenges. As in the right fig, we can see we use the DSCP to mapping the color and make the traffic to the policy. For example, we use the DSCP1 to map the color one in the low delay, low latency the parts for example for the voice traffic for the VIP customers, and the policy B you can only for the other VIP customers for the color 2, and the color 3 is for the normal customers. For how to select the appropriate traffic steering method tailored to the SRv6 specific application scenarios, and ensure the efficient execution. We have that's list some of the traffic steering methods, and we have some initial work referred to the draft gun in this part. And the last part of the problem is that the SRv6 protection deployment practices. So the protection deployment can improve the network stability and the performance, and will enhance the fault handling capabilities, optimize the management and the monitoring, and enhance the deployment experience. As we know, we have a lot of protection mechanisms, like the hot standby for the path protection, and the TFA for the local protection, and like the mirror seat for the egress service protection. So but we require the different deployed strategies. So so many protection mechanisms. We can't put all of them in our network. We need efficient strategies to deploy that. So the problem 8 is that different deployment practices suitable for the different SRv6 protection scenarios. So for this part, some initial work could refer to the draft, and today Changwang Lin will give the presentation of this draft. So that's all. We want to find some feedback from the working group. Thank you.
Are there any questions? One request, like from the very start, it's good to keep the number of authors in your document limited to 5. We really don't want a huge list of authors on the front page. We have faced issues in other working groups at the end, so it's always good to start and discuss this at the start of the work rather than at the end. So just limit the authors to 5, please. And regarding one section, especially related to telemetry, Of course, there is Yang models in Spring which are working, but we should focus that are they collecting the right set of observability metrics or not. Right now, as last time I looked, that was still missing. So it will be good for this group to think about it and provide inputs to the Spring Yang authors on what are the telemetry and observability related parameters that we really care for. So I suggest, you mentioned this in the slides, but there is more work to be done in that area, and we should help in that. Any other questions? Yusong, you are presenting the next one as well, so let's move to that. Go ahead. Yusong, you dropped.
Oh, this one for the Mr. Zhu, we will present the.
Sorry, my bad. Are you online? Yes, please.
Hello, can you hear me?
Yeah, let me connect slides to you.
Hello? Hello?
Yes, we can hear you.
Thank you. Thank you.
There is an echo.
Okay. Hello, my name is Zhu Yongqing. That is Yongqing Zhu from China Telecom. Today, Yisong Liu from China Mobile and me will make this presentation together. Next slide, please. Can you hear me?
Yeah, you can just press the arrow key to change it.
I can.
Don't worry, I'll do it.
Okay, thank you. As you all know, SRv6 it consists of a locator function and arguments. RFC 8986 provides the basic principle of seed allocation by assigning large IPv6 prefixes to the other domain and subdividing them into smaller prefixes for individual nodes. Existing work primarily focuses on basic SRv6 deployments without considering the complexities introduced by advanced features like SRv6 compression and diverse service provider requirements. Here in this draft, we provide a comprehensive and practical guide for optimizing SRv6 seed allocation in diverse deployment scenarios. Next slide, please. SRv6 seed blocks are usually allocated with IPv6 addresses based on administrative divisions and network types. Thus, it will cause two problems. Firstly, the fragmented SRv6 space will hinder SRv6 seed aggregation. As you all know, aggregation simplifies network management and allows efficient use and address space. Secondly, it will complicate the filter of SRv6 traffic at the network edge. Thus will complicate network security and policy enforcement. Next slide, please. So we here sketch to allocate a dedicated IPv6 address block for SRv6 across the entire service provider network. Thus, we can simplify edge configuration by requiring only a single policy for the dedicated SRv6 prefix. Here are two examples for this. Next slide. Next slide, please. Both SRv6 P2P and P2MP utilize unicast IPv6 addresses. It's crucial to avoid allocating SRv6 seats for both P2P and P2MP connections under the same node ID. This can prevent address space congestion and simplify traffic management. So here, we start to define distinct seat ranges for P2P and P2MP traffic flows within network to ensure clear differentiation. Next slide, please. As for food seed assignments, there are two things related to it. The first one is node ID allocation. Flash node ID allocation requires less resources with complex management, while the structured node ID allocation requires more resources with easy management. As for node ID allocation, we can allocate it in statically or dynamic way. The compressed seed assignment is similar to that of proceed. So balancing the length of node ID and function ID for compressed is very important. Due to the inherent length limitations of compressed seeds, a trade-off must be made between the scope of a manageable node and the range of network functions. Next slide, please. And questions?
I have one question. Question related to P2MP.
Or maybe you can go on mute while we're
Is this mic better? No. I'll type my question.
Hey, can you hear me? Hi. Can you hear me? Hi.
Can you temporarily go on mute from the remote? Because there's a lot of
Hi everyone, this is Chang Wanling from New HTC Technology. This draft is about the best practice. Yeah, yeah.
Go ahead.
The next page, please. So background, different deployment practice suitable for different SRv6 protection scenario. Next page, please. SRv6 protection could be divided into path protection and egress protection. In actual deployment, path protection could be divided into local protection and end-to-end path protection. Local protection is performed by the node on the forwarding path. TRFA could be used for local protection, and BFD detecting neighbors or interface could be used for liveness check of local protection. End-to-end path protection is performed by the ingress node. SR policy hot standby path could be used for end-to-end pass protection. When all pass failed, BE protection for SRT pass could be used. BFD detecting SR policy could be used for Leonis check of end-to-end protection. If the egress node failed, the pass protection will not work. The packet should be forwarded to another egress node of the same service. That is egress protection. For egress protection, the penultimate node will perform the local repair, and the ingress node will perform the service FR. And the BFD also detecting the SRv6 or IPv6 address of egress node could be used for Leonis check of egress node protection. Next page, please. Operational guidance for single home scenarios. There are few different pointers for protection in single home scenarios, including as such as TRFA as local repair. TRFA could be tracked by BFD for links and or direct or neighbors. The second, multiple candidate path switched as end-to-end protection. Certainly, BE backup for TE. When link or node failed, SRB path could be still reached to the destination node. When it comes to protecting SRv6 traffic, TRFA tracked by BFD for links and neighbors should be used. For SRv6 traffic, the high SRO case, only the candidate path switch. For faster traffic restoring case, the local protection preferred. First, TRFA tracked by BFD for links and neighbors, and then candidate path switch tracked by BFD for SR policy. BE backup T in case of multiple point faults, a BE backup for T could be used. Next page, please. Operational guidance for multi-home scenarios. In multi-home scenarios, there are few additional protection opportunities available. First, for each egress PE, same as the single home scenarios, including TRFA as local protection, multiple candidate path switch as end-to-end protection, and BE backup for TE. For ingress node switched, when ingress node switched, you monitor the Leonis of egress node using BFD for egress node or validate the ISP routers of egress node. If an egress node failed, the system will automatically switch to another available egress node. Next page, please. The recommended BFD time intervals. Here are the recommended BFD time intervals for different SRv6 protection scenarios. For local protection, BFD for links and neighbors should be sent 10 milliseconds multiplied by 3. Second, track of candidate path switchover. BFD for primary candidate path of SR policy should be sent at 15 milliseconds multiplied by 3. This triggers candidate path switch when the primary candidate path goes down. This provide end-to-end protection with a recovery of less than or equal to 300 milliseconds. Certainly, track of BE backup T BFD for backup candy paths of SR policy should be sent at 100 milliseconds multiplied by 3. For egress protection, BFD for egress node should be set at 15 milliseconds multiplied by 3. This ensure the fast detect of egress node failures and trigger ingress node switch, which switch the traffic to another available egress node. When SRv6 segment list compress is enabled, the repair node will examine the compressed capability of the node along the repair path. It will attempt to use CSID to encode the repaired path. In summary, using CSID such as net CSID or replace CSID enable the repair node to optimize the encoding of repair paths and improve the efficiency in SRv6 network. Next page, please. Yeah, next page. The interop test data for SRv6 protection shows that multiple vendors have successfully passed the interoperability test hosted by China Mobile. These tests were conducted for both single AS and inter-domain scenarios. They indicate a promising trend towards the adoption and implementation of SRv6 protection in real world. Next page, please. That's all. Thank you.
Any questions? Just a general guidance. Right now, this document has two things. It's listing all the various different types of protections that can happen, and then briefly it gives a guidance. But what is needed is we need a rationale for those guidance as well, clearly stating why are you recommending this rather than just giving the output. So that rationale is important. Try to add that. And with respect to having a whole listing, we can see what is the value for that, whether we can simplify that. So this document, we need to think a little bit more how to make sure that the key importance would be understanding the rationale. So let's work on that. That would be my suggestion. Otherwise, thank you. Thanks for bringing this to the working group. And the last presentation, Tianren. Let me give you slide control. Go ahead. Tianren, we can't hear you. Tianren, no audio from your side. Robin, are you there? Is maybe a co-author can present? No, I don't see you.
Tara, you are muted.
Tianren, try again, please. Well, today we faced a lot of audio issues. What's happening?
So Tara, your voice is missed.
Well, there's no audio, in fact. It's not a case of audio being low or anything. Well, let's give it one more minute. Otherwise, we'll discuss this in Dublin. That's a request for anybody remote. We always ask 15 minutes ahead. Please test your audio. There is a reason we do that. Please use that feature from next time. Okay, so calling it. Let's give you 5 minutes back. Thanks for being part of our first working group. And I hope you found the discussion useful, and see you all in the next meeting. Thank you. Bye. Wei-Ching, any
See you.
last words from you?
That's okay for me. I just calling Tianran, but there is no response. It's okay. I think Tianran can present it in next meeting.
And that's why we have the mailing list. Let's discuss it there. Okay, bye.
Okay.